Started. How is everybody? You guys awake out there? So, hi everybody. In this session, you're here to learn about the newest EFS storage class. So we're going to tell you about how you can combine that with EFS's cost optimization features and capabilities, and how all of that combined can help you lower the cost of sharing data for large file-based workloads. My name's Louise Ping. I am the worldwide storage specialist here at AWS. This is Dylan Olivan. He is the head of product for EFS. So let's dive in here. So file storage. It is the most popular storage technique. It's been around for decades. You guys are probably really familiar with it. It's familiar to virtually every computer user out there. It's well suited for storing and organizing transactional data and managing large volumes of data. You can use file storage to easily locate and access individual data items, and you can store just about any type of data. So this helps you simplify collaboration with the familiar file storage interface. Most recently, applications using strictly file-based access rather than database access has increased, requiring high-performance access with low latency. So with all of this, we've seen a surge in the amount of data generated worldwide. This comes from everything from media and video ubiquity, from generative AI, also from the various devices and digital twins. So all of this is increasing not only the challenges, but the opportunities in managing the massive amounts of data. So you might be asking yourself, what does this data growth mean for my business? And how do you use this for your business? But at the same time, you need to ask yourself, do you have a robust and cost-effective data management system that can scale with this large volumes of data? As we continue this session, we will cover how EFS can address both of these questions for you. So optimizing data can be complicated with this ever-increasing volumes that are coming at you. It can be difficult to sift through and figure out what needs to be kept, but maybe not accessed, or how frequently it needs to be accessed. You should always consider how long does this data need to be kept, and also, very important, are there regulations or compliance rules that you need to adhere to? Storing data can be expensive unless you can store that data based on data retention and access frequency requirements. So let's talk about how Amazon EFS helps optimize your storage costs by providing serverless, fully elastic file storage that makes it simple to set up and run file workloads in the cloud. So we have heard from our customers, and a lot of them are using EFS for shared storage needs when deploying analytics and SaaS applications. EFS is a cloud-native file system. It provides bottomless file storage. A lot of our customers like to tell us that it just works, where I don't need to be a storage expert to manage my file data at any scale. EFS is optimized for applications and workloads requiring shared read and write access across multiple EC2 instances or from multiple on-prem servers, such as team file shares, highly available enterprise applications, analytics workloads, and ML training. So EFS, Amazon Elastic File System, is designed to provide configuration-free, fully elastic file storage that lets you share file data without provisioning or managing storage capacity and performance. It can be used with AWS services and on-premises resources. It is accessible from anywhere, and it's built to scale to petabytes without disrupting applications. We have fantastic features such as intelligent tiering. Intelligent tiering automatically optimizes costs for shared file storage when data access patterns change and no operational overhead needed. So the most common things that you should consider as you work towards not only reducing costs, but ensuring your business has the highest performance output are the following. So think about your overall operational costs. With a fully managed file system, you don't have to worry about provisioning, deploying, patching, maintenance, or software licensing. You also should think about the storage capacity and performance and what you need in order to run your applications and workloads. So how much storage is needed, as well as latency, throughput, and IOPS. And then, of course, any rarely accessed data, can that be moved to colder storage, saving you money? So the typical priorities that we've seen with rationalizing your operational costs are a combination of efficient resource management, technology upgrades, and strategic planning to align storage infrastructure with actual business needs. The other thing that you're going to have to get behind is the regular reviews and adjustments that will be required in order to ensure your infrastructure remains cost effective. So in traditional on-premises infrastructure, there are several costs that you should consider. Things like the cost of the data center space, the power required, and the cooling, the cost of building and maintaining a network, hardware and software maintenance expenses, and of course, headcount. You need people that can ensure that this infrastructure stays operational and secure. So you often hear us talk about something being fully managed. For EFS, what does fully managed mean? So fully managed for EFS means it is designed to provide the simplest experience for customers without any configuration. So that means customers can create and configure file systems without having to worry about managing file servers or storage. This means that all of the updating of hardware, configuring software, and performing backups, all of that is automatic, and you don't have to manage that. So I want to change gears for a moment and talk about how data is stored in EFS and the architecture behind durable data storage. AWS has the concept of a region, which is a physical location around the world where we cluster our data centers. We call each group of logical data centers an availability zone, or AZ. Each AWS region consists of a minimum of 3 isolated and physically separate AZ within a geographical area. So what that means is these availability zones, or AZs, enable you to operate production applications and file systems that are more highly available, fault tolerant, and scalable. For EFS to achieve these high levels of durability, we have 2 classes. We have standard class and one zone storage class. So standard class is where all files and directories are redundantly stored within and across multiple availability zones. One zone storage class means your data is redundantly stored within a single availability zone. So EFS file systems can withstand the full loss of a single AZ while still providing the same quality of service in the other AZs. EFS is designed to sustain concurrent device failures by quickly detecting and repairing any lost redundancy. Customers can access the file systems that use EFS standard concurrently from all AZs in the AWS region where it's located. Finally, you can architect your application for failover from one AZ to another AZ in the region for a higher level of application availability. So with security and compliance, there are two fundamental goals when applications are accessing shared storage. So you have to think about that your data is only accessible from a certain set of clients. So that's one. Number two is ensuring the proper credentials and permissions are provided to access specific pieces of data. EFS is designed to provide secure access for thousands of connections for Elastic Compute Cloud, or EC2, and for AWS container and serverless compute services. It also provides support for on-premises servers using a traditional file permissions model, file locking, and hierarchical directory structure through the NFS v4 protocol.
Thanks, Louise. So, as Louise mentioned, there are typically 3 different priorities that we see builders keep in mind when trying to optimize their storage costs. And with EFS, you don't have to do the hard work to rationalize your operational costs because we already provide a fully managed experience for your shared file storage. Let's dive a little deeper into the second way that we typically see builders optimize costs, which is really about determining the exact storage capacity and performance needs that your application and end users need, and then really trying to thread the needle on provisioning exactly what your applications and end users need to reduce your costs. So we see builders do this pretty often and try this approach, but why is it so hard? Well, I think the fundamental truth is that it's hard to forecast the future. It's hard to predict how your needs will evolve, how your end users' needs, how your applications will scale, and how your customers potentially using your service that's built on EFS will grow over time. And the interaction of all 3 of these things make it even more challenging for you to forecast what type of storage capacity and what type of performance you'll need a month from now, a year from now. And with these challenges, you're really stuck between a rock and a hard place. You can lower costs by under-provisioning, but that means that you end up slowing down your end users and applications and slowing down your ability to extract value from your data. Conversely, you could over-provision and make sure that you're always delivering the storage capacity and performance that your applications need. But the challenge with that is you're increasing your cost. You're paying for idle, underutilized resources that aren't generating value. Well, luckily, with EFS, builders like yourselves don't have to think about planning or provisioning at all. So we deliver a fully elastic experience across 2 dimensions. So since the inception of the service, EFS has delivered fully elastic storage from a capacity perspective, which means that you get virtually bottomless capacity that automatically scales up as you add data and scales down as you remove it, and you only pay for exactly what you use. And more recently, we extended this elastic concept to performance, and EFS now delivers just works elastic performance for throughput and IOPS intensive workloads that customers are trying to run on shared file storage. So since this is a new concept, let's dive a little bit deeper into what elastic performance really needs. Well, it doesn't mean that EFS will scale to infinite performance, though we're certainly working towards that on our roadmap. What it really means is that you don't have to provision or know how much performance you need up front, and EFS will automatically scale to the maximum performance limits that we support for any of your EFS file systems, no matter how much data you have in it today or how much data you think you'll have in it tomorrow. So at reInvent last year, we launched a new throughput mode called Elastic Throughput that really aimed at delivering this experience. It's a pay-as-you-go throughput option, which means that you only pay for the performance that you're using, and EFS will automatically deliver it if your end users and applications are driving that performance from your EFS file system. And what that specifically helps with is we hear a lot of builders don't know how much performance they need from their shared file storage. It's actually a pretty tricky question even for storage experts. So with Elastic Throughput, you don't need to know that number up front, and will automatically scale so that you're always extracting as much performance as you need to support your use cases and workloads. But what does this look like in practice? So we received this pretty compelling graph from one of our colleagues at SAP. And we'll dive a little bit further into their use case shortly, but they run an application on EFS shared storage, and they recently activated Elastic Throughput to help them optimize costs. They had been using provision throughput in the past, so provisioning a specific level of performance up front. And what they found with this exercise is that they were over-provisioning performance. They didn't need as much performance as they had been setting on their file system. And by turning on Elastic Throughput, they were able to reduce their costs by as much as 80%. So this is an example file system, the cost that they were paying for throughput on that file system. And you can see a precipitous drop as soon as they activated Elastic Throughput. And so they reduced their cost by 80% without impacting their application performance at all. But you might be wondering, what about the actual performance and scalability we deliver with this Elastic Throughput pay-as-you-go experience? Well, I'm happy to share that even just over the past year, we've been continuing to raise the bar on EFS's performance capabilities. When it comes to storage, there are really only 3 performance dimensions that matter. There's latency, which is how fast you can grab the first byte of data in a file. And at reInvent last year, we improved our latencies by 2x. So we lowered our latencies by a factor of 2. The second dimension is throughput. So how much data, how quickly can you read or write data from your file system? And in April this year, we increased our per file system throughput limits by 3x and support up to 10 gigabytes per second of throughput. And again, all of this is automatically delivered to your file system on a fully pay-as-you-go basis, and you don't need to provision it up front in order to get it. And the last performance dimension that matters for storage is IOPS, so the number of operations per second. So think about transaction-heavy workloads that are typically reading or writing a lot of small files over and over again. And August this year, we increased our IOPS limits on EFS by 3.6x. So now support up to 55,000 read IOPS and 25,000 write IOPS. And I'm happy to announce that at reInvent this year, we're continuing to invest and deliver on IOPS scalability and have increased our maximum IOPS limits per file system by another 4.5x. So we now support up to 250,000 IOPS on the read side and up to 50,000 write IOPS on the write side. So making it even easier to deliver fully elastic shared file storage for high IOPS transaction-heavy workloads that customers are bringing to the AWS cloud. So the third priority, or the third way that we typically see builders optimize costs, and really the focus of this session, is by moving their cold data to colder storage. But before we dive in, let's talk a little bit about the why. So why do builders need to move data to cold storage? Well, when you look at a typical file share, and we know this from managing millions of file systems over the 7 years that EFS has been around, there's usually a mix of data within a file share. You have, if you think about the shared drives that you and your team might be working on, you typically have an active subset of your data, which is the documents or projects that you're working on right now. And that's often about 5 to 10% of your data. And you also have the inactive subset of your data. So think about stuff that you worked on last month, might be looking at once every couple of weeks. And you're not working on it actively, but you keep it around just in case you need it. And then last, you have your really cold data. So projects that you worked on a few months, few quarters, even a year ago. You're not likely to touch that data, but you never know. A client might reach out and want to do another revision, or you might want to incorporate this and combine it with something you're working on right now because you think some of that work has value. So with this mix of data, it's really typically pretty challenging to find the right storage solution for each of these kinds of access patterns. And what's more is that your files or your data is typically evolving across these categories. What's active this month isn't going to be active next month. What's cold this month isn't going to be cold next month. So we see builders struggle with this a lot. Because what they typically try to do is they try to move their inactive data and cold data into cold storage. So you have your active file share that your end users and applications are working with. And then you have a separate cold storage solution, sometimes backed by tape-based asynchronous storage to really reduce costs, that houses your inactive and cold data. And some customers even resort to deleting this cold data when they're really pinched to reduce costs. So why is this so challenging? Well, first, as I mentioned earlier, your access patterns are continually evolving. So it's really hard to monitor which part of your data set is cold or hot and keep track of that over time. And second, deleting data is irreversible. It's a one-way door decision. Here at Amazon, we talk a lot about one-way door decisions because you can't undo them. Once you delete data, it's not coming back. And if you find out one day that you needed that file, that component of your data set, because it's critical for a new analysis, you're out of luck. And lastly, managing this data movement, if you do decide to move data to cold storage, is really complex and slows you down. So as I mentioned earlier, you need to track which subset of your data is cold. You need to set up processes to move that into colder storage. And when your end users and applications are trying to work with that data that you've moved, you need to have a separate process that goes and finds it and brings it back to the file share so that they can collaborate on it again. And retrieving some of this data from those cold asynchronous storage solutions can sometimes involve hours of data retrieval time. And when it comes to delivering mission-critical insights, all of those hours matter. Well, luckily, on EFS, we've made this a lot easier for builders to benefit from automatically cost-optimized storage. So how do we do that? Well, first, we support two different storage classes, or supported two different storage classes already. We have EFS Standard, which is designed to support your active data set, so deliver really the fastest latency performance for the data that you're trying to work with the most. And we have EFS Infrequent Access, which is a cost-optimized storage class for inactive data. So it delivered a storage cost 92% lower than EFS Standard, but with latencies that are a little bit higher than what EFS Standard could deliver. And what's more is that we support automatic intelligent tiering across these storage classes. So you don't have to track access patterns. We do all that heavy lifting for you. As data becomes cold, we tier that data down to colder storage, down to the infrequent access storage class, so you can benefit from 92% lower cost on those cold files. And you can also set a policy to promote data back to standard, so back to the high performance storage when you touch it. Because what we typically see is when you touch a file, it's an indication that you're working on it again. And so promoting it back to standard means that while you're working on it, you benefit from the best performance that we can deliver. And what's more is that with this intelligent tiering experience, all of those files, all of that data is available from a single EFS file system, so a single namespace. Your end users and applications are completely blind to where that data lives. It can live in standard, it can live in infrequent access. They can work with it just like they work with any other files in this file system. And you automatically reduce the costs of storing that data on EFS. And so this is a pretty good experience. And a lot of customers are benefiting from it today. But at reInvent this year, and just yesterday, we launched 2 separate improvements to EFS's storage classes. So first, we launched a new lower cost for the existing EFS infrequent access storage class. So we lowered the cost by 36% from 2.5 cents per gigabyte month down to 1.6 cents per gigabyte month, which means that EFS infrequent access is now 95% lower cost than EFS standard, making EFS a even more cost-effective solution for storing your active and inactive data. And the second is, in the title of this session, we launched a new addition to EFS's storage classes called, a brand new storage class called EFS Archive. So with standard and IA, we have purpose-built storage classes for active and inactive data. And customers asked us for a more cost-effective way for storing their super cold, rarely accessed data. So think about those files that are accessed a few times a year or even less. And with EFS Archive, we've delivered a storage class that's 0.8 cents per gigabyte month. And with that, EFS Archive is the lowest cost file storage class offered by AWS for your rarely accessed data. And with EFS Archive, you get the same experience that builders love about EFS. You get the same instant access, so milliseconds of access, same gigabytes per second of throughput performance that you get from EFS's other storage classes, and the same high availability and 11 nines of durability that Louise talked about earlier. With EFS Archive and EFS's existing storage classes, you can now share all of your data set, from your hottest, most frequently accessed, most performance-sensitive data, down to your coldest, least frequently accessed, rarely accessed data, all from a single namespace solution for your end users and applications. And this new storage class enables you to save up to 50% compared to even the reduced price of EFS IA that we announced yesterday. And so what does a file share look like on EFS now with this new storage class? Well, we talked about how file data sets typically have active data, inactive data, and cold data. Now EFS offers storage classes that are purpose-built and aligned to each of these different types of access patterns. And you get automatic intelligent tiering across these storage classes based on those access patterns. So we do all the heavy lifting for you. You don't have to monitor your access patterns. We move your data to the right storage class that delivers the performance you need and the price you need. And all of this data is instantly available to all of your end users and applications from a single namespace, which means they can easily collaborate on this data, whether it's in the archive storage class, the IA storage class, or the standard storage class. And with EFS Archive, you now have a storage solution that enables you to keep even your coldest data instantly accessible should you need it again. So let's switch gears a little bit and talk about a little bit more about what this looks like in practice. So let's start with a couple of customer examples. So let's start with CubeRT. So CubeRT is a quantitative asset management firm based out of the UK. And they use EFS to provide simple shared file storage for their teams of hundreds of quantitative researchers. And they were looking for a way to optimize costs without slowing down the research and the quantitative processes that their teams were delivering on this shared file solution. Obviously, every minute counts when it comes to developing quantitative asset management strategies. And with EFS's infrequent access storage class, they were able to significantly reduce their cost across petabytes of data that they were storing on EFS without impacting performance at all. EFS infrequent access automatically tiered just their colder data set, so none of the active, frequently accessed, performance-sensitive files suffered any performance penalty, and they were able to maintain the same high performance that their researchers were used to. Let's also talk about SAP. So we shared how SAP had optimized their costs using elastic throughput. But when we look at how they leverage all of EFS's cost optimization features, with EFS's infrequent access storage class, they were able to deliver up to 50%, over 50% storage savings, while maintaining the same high availability and performance they need. So SAP uses EFS to support their Rise with SAP application, which is a ERP in the cloud offered as a service for SAP customers. And not only were they able to deliver 50% savings on storage with EFS's infrequent access storage classes, but they were able to deliver an over 40% savings across their EFS bill with a combination of EFS infrequent access and elastic throughput. And they expect to deliver even more savings when they take advantage of EFS Archive that we just launched yesterday. So with EFS's cost-optimized storage classes and flexible throughput modes, they were able to reduce costs while maintaining the same reliability and performance that their customers relied on from their Rise with SAP applications. So let's take a look at how easy it is to set up EFS Archive. So launch a brand new storage class. It really fits right into the simple experience that our customers already rely on for EFS. So when you create a new file system, we automatically include EFS Archive as part of the intelligent tiering policy that we apply to the file system. You can customize it, and essentially you set up intelligent tiering by setting a schedule for when data gets moved to the infrequent access and archive storage classes. And by default, we apply the recommended policy based on our experience working with customer file systems of 30 days without access moves your data to IA, and then 90 days without access moves that data to the archive storage class. And so we apply this by default, this recommended policy, and you're able to customize this policy to meet the needs of your specific use case, your specific workload. And for an existing file system, it's just as simple. You can edit the lifecycle policy of an existing file system to update the transition to archive property and set that to whatever you think would best fit your use case. Again, our recommendation is a 30, 90-day policy based on our experience working with customer data. And so I also wanted to share a couple of considerations when using the EFS Archive feature. First is, as I just mentioned, it's enabled by default. So when you create a new file system, your data will get tiered to IA after 30 days and tiered to archive after 90 days. So by and large, 80, 90% of customers, especially new customers, will automatically benefit from this feature. The second is that EFS Archive delivers a 50% lower storage cost for data at rest, but it does include a higher data access charge. Right, so infrequent access is designed for your inactive data that you access a few times a quarter, and archive is designed for your rarely accessed data that you access a few times a year or less. And the way we do that is by offering a lower storage cost, a lower data at rest cost, and a higher charge when you read that data. The third thing is that we support the new lower IA price and the EFS Archive storage class only on EFS file systems using elastic throughput. So elastic throughput is the fully elastic performance experience that we're hearing resoundingly from customers, that it's the simple experience they want from their file systems. So we're really looking for ways to optimize costs for customers that are using this experience. So we're only supporting these lower storage prices on elastic throughput file systems. And the last thing is really an improvement to how we handle small files on EFS's cost-optimized storage classes. So we're launching an update as part of this launch that aligns how we handle small files with how S3 handles small files on their S3 infrequent access and S3 Glacier instant retrieval storage classes. So files smaller than 128 kilobytes can now be tiered down to IA or archive, but they'll get billed as if they're 128 kilobytes. So we'll have a 128 kilobyte minimum billing increment for these two storage classes. And with the 95%, 97% cost difference between IA and archive and EFS standard, there's still tremendous savings that you can get for even the smallest file data that you have. And so to close, I wanted to share a couple thoughts about EFS and about EFS Archive. First is why customers like EFS. They like EFS because it just works. So you don't need to think about complex configurations, and we deliver a fully elastic experience without any provisioning. It's easily accessible across different forms and virtually all forms of AWS compute, so you can design your architecture and have EFS fit your architecture instead of the other way around. And then lastly, it's automatically cost optimized, and we just delivered 2 improvements to this automatic cost optimization experience with our new lower IA price and the new EFS Archive storage class. And then to recap on EFS Archive itself, there are 3 things that I think I'd like you all to remember. The first is that the easiest way to think about EFS Archive is it's the EFS or file analog of S3 Glacier instant retrieval. It's a storage class that's specifically cost optimized for data accessed a few times a year or less, but is still instantly accessible, so milliseconds of access. The second is the value proposition for this storage class and EFS's 2 other storage classes is really that we support automatic tiering of your files without any data movement on your side across these storage classes, so all of that data is available from a single namespace, a single shared file system for your end users and applications. So these storage classes are virtually transparent to anybody that's actually working with the data. And then the last thing is that EFS Archive helps you save up to 97% compared to EFS standard with a price of less than 1 cent per gigabyte a month, so 0.8 cents per gigabyte a month, and enables you to save up to 50% compared to even the reduced price that we just announced for EFS and frequent access, making EFS a cost-optimized solution for virtually any data set. And with these cost optimization features, you still get the full elasticity, the simple experience that EFS delivers today. So if you'd like to learn more, I'd recommend that you go to aws.amazon.com/EFS, and Louise and I will be available to answer any questions on either end of the stage. But thank you for listening. Super excited for this launch and excited to see what customers do with this new feature.
Please fill out the survey. Don't forget that.
Oh, and please fill out the survey.
They'll yell at us if we don't say that at the end.
All right. Thank you.
Thank you all.